Welcome to another GCBASIC demonstration. This demonstration is going to show you again how to use PICKIT2 and PICKIT3 within MPLAB X. Like and subscribe, watch the video all the way through. The only way to get the matrix to work on YouTube is if you like and subscribe. Okay, so what we're going to do is cut the simple things, right? Create a project, make some LEDs flash, see that work. Then we're going to create a project in MPLAB X. We're going to use the output from GCBASIC as a source. I'm actually going to change the order. I'll do a debug first, okay? And we can see it being debugged inside of MPLAB X, and then we'll do some programming using the PICKIT. So what have I got? I've got a box like this, look. These are readily available on eBay. They're dirt cheap. I mean, why people are paying big money for big programmers, I have no idea. So let me just put that past you. I got this one the other day, sent actually to me. Someone said, is it any use? Of course it is. That's a 16F690. I know by looking. There we go. No need to zoom in. That's it, sort of there. Can I see it? Let's just make sure that it's sort of operating as I expect. So let me just open up PICKITPlus for PICKIT2. There we go. Open it up. And I'll zoom in on that for you. Yeah, it's found it. Look, a 690 there. Look. There we go. A 690. It's let's start GCBASIC. Type in, open the window, GCS, GC Studio. I'm going to create empty project. So rather than, I'm just going to create continue without code, empty screen. There we go, empty screen. And the first thing I'm going to do is file, new text, and then save it straight away. Save as. So you can see it. I'll change my screen size. C column, actually that's temp, put any file name in it, just so you can find it. MPLAB, I do this quite a bit, so MPLAB 100.gcb. .gcb is important because it then brings in all the GCB syntax. So that's chip 16F69. It's automatically filling all this in for me. That's really good. Hit enter. I've just specified the chip. Option explicit, specified my must define my variables. I'm just going to set the output LEDs on that thing you just had a look at to an output. And then I'm going to do a do loop. I'm going to toggle the LEDs, port C, they're all on port C, not port C, that will just toggle it for us. I'm not going to explain why that works, it's just a not sign and it will do it for me. And all I'm going to do now, look, is I am going to show you my setup in terms of my configuration. So I press function key F4, type in prefs, edit preferences, and it'll open up the edit preferences editor for me. I can show you the zoom in on that for you. Look. And I'm using, at the top of my list here, I can drag and drop this as a PICKITPlus, maintain the power, and my compiler option is GCASIC. That's good for now. Let's go into this mode, press function key F5 inside of here, inside of the GC code editor. It's compiling it up for us, and it's downloading it, and it is now programming it. And it's just done all that in a few seconds, and it's flashing the LEDs. We know it's working. And it says all that on the screen here. It says it compiled it, it assembled it, it then programmed it. And it all works. We know that works. So what we're going to do some of that in MPLAB. Let's do the same. Why don't I erase it? I'll erase the chip so that we know that we're doing it in MPLAB. erased. Okay, back into the IDE here. I am going to change the compiler slightly here, or the tool chain slightly, press function key F4, open the preferences again, and I'm going to ask it to do a compilation, but this time using PIC-AS. PIC-AS is the assembly language that's now used inside of MPLAB. So if you go PIC-AS in that little drop down, press OK. And you can program it again. We can call out to MPLAB and use the hexadecimal file that's generated within GCBASIC and program it. But what we're going to do is use an intermediary file that's automatically created to show you. Okay, so now in here I'm going to show you longhand function key F4. Make the hexadecimal file, but this time it's going to reach out into PIC-AS. I'll just bring that up so you can see it. And it said here, look, let me just look, assembling using PIC-AS, compiled. Warning's been generated. That's just a small patch that's been added in. That's not a problem. But it basically says, look, it's assembled using PIC-AS. Well, if PIC-AS is part of MPLAB, we got a green light from MPLAB already. So let's just fire up MPLAB and use this file that's been created. But what file has been created? It's called a .s file. So if you press function key F4 again and type in the word open, there's the old assembly file that you used to be able to use. Now you have a .s file. Open that, and it opens a slightly different file, and it's the file that's compatible with MPLAB. So what I'm going to do, I'm going to take right-hand mouse button on there and just take a copy of the path. It's in the cut and paste buffer. All right, let's start up MPLAB. MPLAB version 6.25. That's the latest version. 6.25. There it is, and it's opening up version 6.25 for me. We're going to create a project, and then we're going to use that source file from GCBASIC in here. It takes longer to open MPLAB X than it does to compile. Okay, great, here we go. So I'm going to zoom in because it's a bit on the small side. File, new project, and select the following: microchip embedded application. Next. Type in the chip name. Well, the chip name we know is 690. Just a bit of a cheat there. I happen to know that if you just type a little bit of it in, it does it. You can select the simulator here. Press next. So enter the chip name and simulator. You don't have a debugger header, so that's fine. And then in here, because we're going to want to use PIC-AS, type in, just expand that and just pick the top one, version 3 or later, depends what's installed on your machine. Fine. And then I'm going to give it a name of 16F690. And I am going to go finish. It's set up the empty project for us. It's empty. There is no code. There is no auto generation because we're going to take the file. We're going to add into our source file here on the top right-hand corner, source file, add in an existing item. And that existing item is from GCBASIC. So if you remember, I put it in my cut and paste buffer. C column temp MPLAB 100.s. Select auto. If it's not selected, select. We've added it in. Let me just bring this up a little bit so you can see the whole thing. Not it. Let's put it there. That's the whole screen. Why am I doing that? Because we're going to compile this inside of MPLAB X now. And you might go, it's not going to do it. Build the project. Build, and it's done it. Well, we already knew it was going to do that because it did it inside of GCBASIC. We used the same infrastructure, but it's built successful. So what I can do, I can warp the code in the debugger inside of here now. Look, watch. Debug, discrete debugger operation, build for debugging main project. This is the process. You must do that. It creates the intermediary files that are necessary. Debug, discrete debugger operation, launch debugger main project. It's got a breakpoint. It always stops at that breakpoint. Now you can then look at things like window, debugger, IOV. Oh, I'm so sorry. Window, debugger, IO view. Let's select port C. And then if you press, you have to work out what the keys are, but debug, F7 will walk the code. I'm going to walk the code by pressing F7. It goes into F7. I want you to see it inside the .s file, and all the green stuff in here, all the comments from GCBASIC. So you can see the GCBASIC code that's been generated, and you can walk it. This is initializing the chip. It's now setting the tris for you automatically. It's going to toggle using COMF, which is an assembly instruction, port C, and we'll see that happen in the IO view. And there we go, all the LEDs are just toggled. And if we waited 100 milliseconds, it will come and do it again. But what I can do is I can put a delay in here. And where's my delay? I can go back to my COM statement. Where was it? It's very small on my screen here. I'm going to double click on the left, make it go red. I put a little break in it so I can break the code, and if I press F7 again, it turns the LEDs off. So you can then walk the code and learn the code. Why don't we program it from inside of here then? So how do I do this? I have to go File, Project Properties of this project, the 690 project. And then to program it, you go into the Building tab here, sub-tab, execute this line after the build, and I'll go and get that line. I'm going to get that line from the post I made recently up on Ko-fi. And if you look carefully on Ko-fi, here is the command line in its entirety. Let me just move that across so you can see it. I'm just moving my screen about. I've just taken a copy of that back into MPLAB and just paste it into here. And that has got my PICKitPlus installation, my command line, all the parameters all set up for me. Press OK. Desk cam. Let's go into this mode here so we can see what's happening. Production. Build main project. I'm going to compile it. As you can see, the PICKit is flashing. Voila. You can use it. You can understand the way the assembler works without getting involved in C. It's a really useful way of doing things. So native support for PICKit 2 dropped a long time ago. Native support for PICKit 3 dropped out of MPLAB X at the previous release. That's 6.20. You can still use these things, but you can't use them within C. So I wanted to go show you all that. I will go back to my PowerPoint. So I made some assumptions that you had GC Studio, MPLAB X, and PICKitPlus software, and you had a microcontroller like this one. So that is using a PICKit 2. It could have been a PICKit 3. I happen to use PICKit. It's exactly the same process, no different. It doesn't really matter, but that's what I wanted to show you. That's a quick video on how to use PICKit 2, PICKit 3 in MPLAB X. Enjoy.